This is a submarine, this is a boat, or maybe a barge. Now try to guess which one of these is the key to a top-secret $200 million CIA mission to steal a sunken nuclear submarine from the depths of the ocean. Maybe it's this one. Well, nope. That's just a regular old submarine. Here's another hint. How about now? Still not sure? Well, both of them are wrong. This innocent-looking boat is Project Azarian's weapon of choice, a submarine killer that operated silently beneath the waves. But don't be fooled. There's nothing ordinary about this vessel. This is one of the most insane ships ever built. This is the Hughes Glomar Explorer, and this is the story of how the CIA turned an ocean mining vessel into a deadly submarine hunter. Built in 1974, the Hughes Glomar Explorer was no ordinary ship. It was a 611-foot-long behemoth that looked like a mining vessel, but was secretly a highly advanced submarine hunter. Its hull was hollowed out to hide a massive claw-like device that was lowered into the water to capture submarines, officially named the capture vehicle, but unofficially nicknamed Clementine. This crane-like contraption weighed as much as a jumbo jet. Why? Because it was designed to lift extremely heavy objects from the ocean floor. In this case, a 2,000-ton Soviet submarine. The claw was lowered on a 3-mile-long steel cable winch attached to a giant arm on the side of the ship. How does it work? Well, it's pretty straightforward. The claw would grasp the submarine's hull, and then the winches on the side of the ship would start reeling it in, lifting the submarine to the surface. Simple in theory, yes, but keep in mind that this claw was designed to salvage items at a depth of 16,500 feet and withstand the crushing pressures of the deep ocean. At that depth, the weight of the water above creates tremendous pressure. In fact, every 33 feet of water creates an additional 1 atmosphere of pressure. Imagine being 165 feet underwater, where the pressure is 5 times greater than at the surface. That's the environment this mechanical marvel was meant to thrive in. The claw's basic design consisted of 6 curved metal fingers. Each finger was 10 feet wide and lined with rubber padding to prevent scratches on whatever object it was grabbing. But the real magic was in the tensioning system. Each finger had a hydraulic piston that allowed the operator to tighten the grip. In fact, these pistons could generate over 100 tons of force, enough to securely clasp a submarine's hull. The pistons also came with sensors that could measure the force they were exerting, making sure that whatever was being salvaged wasn't crushed under the pressure. However, the claw wasn't just meant to grab and hold. It was also equipped with lights and cameras to inspect whatever it was holding. These features enabled the crew on the ship to monitor the claw's grip and ensure a secure hold. Additionally, the claw's cables were rigged with pressure sensors. They alerted the crew to any sudden changes in pressure, indicating the claw might have slipped or encountered something unexpected. The final feature of this intricate machine was a cutting system, a vital component for releasing whatever the claw had grasped. Located at the base of each finger, the cutting mechanism was activated by a hydraulic motor. The moment the claw had to release its hold, the motor would retract the cutting blades into their protective casings. The whole process was carefully planned and executed. The submarine salvage operation required precision and skill. Despite looking like something from a futuristic sci-fi film, this claw was a product of practicality and innovation. It may not have been able to crush submarines like a giant pair of metal tweezers, but it did manage to snag one successfully. Here's how it happened. The first step was to locate the submerged submarine. This was uneasy as we were talking about an object roughly the size of a school bus sitting at the bottom of the ocean. But luckily, the CIA had a head start. They knew approximately where the submarine was located, thanks to the US Navy's top-secret SOSUS system. SOSUS, or the Sound Surveillance System, was an underwater microphone network that could listen in on submarine activity. It was like having ears in the ocean. So using SOS-US data, the Glomar Explorer set course for the target. Once near the crash site, the submarine hunter got to work. It was time to deploy Clementine. Slowly, methodically, the crane-like device was lowered into the murky depths. It descended at a speed of around 1 foot per second. At this pace, it would take nearly 15 minutes to reach the bottom. But remember, we're talking about a depth of 16,500 feet. Precision was paramount. The claw had to be lowered accurately to capture the submarine. On board the ship, a team of experts monitored everything. Cameras and lights on the claw provided a live view of the situation. Sensors measured pressure and tension. The crew was looking for the submarine and preparing to strike. Finally, after a nerve-wracking descent, they spotted their target, the K-129, lying on the seabed. It was severely damaged and covered in marine life. The submarine had been at the bottom of the ocean for years, but despite the challenges, the Claw was about to attempt the impossible, lifting a wrecked submarine from such a great depth. Now it was time for action. The crew guided the Claw into position and closed its 6 massive fingers round the submarine's hull. The submarine wasn't moving. It was trapped in a vice-like grip. The tension was palpable as the Claw started its ascent. It was a delicate dance. The submarine was incredibly heavy, and the Claw had to move slowly to avoid putting too much strain on its mechanisms. But as the submarine began to surface, something went terribly wrong. Suddenly, the Claw malfunctioned. 6 massive fingers that had been holding on for dear life started to tear away. Within seconds, the submarine slipped out of its grasp and plunged back into the darkness of the deep sea. Only a small portion of the submarine was salvaged. The submarine killer hadn't managed to slay its prey, so the CIA had to try again. The mission was a partial success. They recovered the nose cone of the submarine, which contained valuable intelligence, including 2 nuclear-tipped torpedoes and the remains of 6 Soviet sailors. The submarine killer hadn't triumphed, but it had done its job well enough. As for the rest of the submarine, well, that remained at the bottom of the ocean, a secret known only to the CIA and the Soviets. The Hughes Gloom Explorer was a remarkable feat of engineering. The Claw may not have been able to lift the entire submarine, but it did manage to recover some crucial information and remains. It was a testament to the brilliance of those who designed it and the bravery of those who operated it. But perhaps the real story is the silence that followed. Neither the Soviets nor the public knew about the daring mission until years later. The Hughes Gloom Explorer had done its job and then slipped back into the shadows, leaving behind a tale that was equal parts adventure and intrigue. The Hughes Gloom Explorer was a groundbreaking achievement in submarine salvage technology. Its ability to operate at extreme depths and withstand immense pressure opened up new possibilities for underwater exploration and recovery operations. But it was top secret for decades, only coming to light in recent years. Today, modern submarines like the Deep Sea Worker use remotely operated vehicles controlled from a surface ship. These ROVs can reach even greater depths and manipulate objects with greater precision than Clementine. Advanced imaging technologies allow real-time monitoring of the situation, aiding in the safe recovery of valuable items or research equipment. As technology continues to evolve, it's likely that future submarine salvage missions will become even more precise and efficient. Maybe one day they'll even perfect the remote control claw. Who knows? Maybe in the not-so-distant future, we'll see a submarine hunter that can gracefully pluck submarines out of the water with ease.